You know, whenever we throw on a sci-fi movie, artificial intelligence is almost always shown as some glowing, hyper-intelligent android, right? It's usually either about to save the entire galaxy or totally take it over. But the actual reality of AI today, it's vastly different, and honestly, I think it's a whole lot more fascinating. So in this explainer, we're definitely not looking at Hollywood scripts. Instead, we're going to explore the actual real-world academic map of artificial intelligence. Think of this as your personal guide to understanding exactly what AI is right now and what it might actually become tomorrow. Let's get into it.
Okay, let's dive into this. Here is our roadmap, basically our syllabus for today. First up, mapping artificial intelligence. Then, classification by capabilities, followed by classification by functionality. And finally, we'll wrap up with real-world AI in action.
All right, Section 1, Mapping Artificial Intelligence. Let's look at the big picture and set up our foundational framework.
Now, what's really interesting about this setup is that artificial intelligence isn't just one giant bucket. Experts actually divide it into two distinct branches. On the first branch, we have Type 1, which classifies AI based entirely on its capabilities, essentially what it has the raw power to actually do. On the other branch, we have Type 2, which classifies AI based on functionality, so how the system actually processes the world, handles memory, and quote-unquote thinks. Literally every single piece of AI you interact with fits somewhere on this map.
Moving right along to Section 2, Classification by Capabilities. Think of this as a chronological timeline of AI's power and potential.
So when we look at capabilities, there's a very clear ladder to climb. Step 1 at the bottom is narrow AI, which is sometimes called weak AI. This is simply an AI dedicated to performing just one specific task and doing it well. Step 2 is general AI. Now this would be a system that could perform any intellectual task with the exact same efficiency as a human being. The idea here is a system that can genuinely think for itself, but to be clear, this does not exist yet. Researchers worldwide are still actively trying to develop it. And finally, step 3 at the very top is super AI. This is a massive, world-changing, hypothetical concept. It's an outcome of general AI where machines completely surpass human intelligence, possessing the ability to reason, solve complex puzzles, make judgments, and learn entirely on their own.
So, where exactly do we currently stand on this incredible ladder? Well, firmly at narrow AI. That's our "you are here" anchor for today. The most common and honestly the only currently available AI in the world right now is entirely narrow. Whether it's your smart assistant, a computer playing chess, e-commerce shopping suggestions, or modern speech recognition, it's all narrow AI. And here is the really crucial catch. Because it's only trained for one specific task, if it goes even slightly beyond its limits, it fails in highly unpredictable ways.
You know, even when an AI looks absolutely incredibly powerful, it is still rooted right there in that first step. Take IBM's Watson supercomputer, for example. This massive, glowing machine looks like pure science fiction, but it's actually a prime example of narrow AI. It was originally designed specifically for question answering in natural language, using an expert system approach combined with machine learning. So it's undeniably brilliant at what it does, but it is strictly dedicated to a singular domain.
Let's move to and see how this builds in Section 3, Classification by Functionality. This is where we shift from what AI can do to exactly how it thinks, processes, and handles memory. The absolute most basic functional type of AI is the reactive machine. These systems don't store memories and they don't use past experiences for future actions. They solely focus on the current scenario right in front of them and react with the best possible move. A perfect example of this is Google's AlphaGo. Developed by Google DeepMind, AlphaGo plays the incredibly complex board game Go simply by evaluating the board exactly as it is in that specific moment. IBM's old chess-playing computer, Deep Blue, operates on that exact same reactive principle. There's no learning from the past, it's literally just reacting to the present.
But what happens when we give a machine just a little bit of memory? When we contrast these two, we move from reactive machines, which have zero memory, to limited memory AI. A limited memory system can actually store past experiences or data, but only for a very short period of time to help it navigate a specific task. Self-driving cars are absolutely the perfect example of this. Think about it. To safely drive you down the street, these cars have to temporarily store the recent speed of nearby cars, the distance of other vehicles, and the current speed limits. They use this short-term stored data to perceive the environment and navigate safely.
Now, let's speed things up a bit and look at the future of functionality, which frankly is a little eerie.
The next functional step up is theory of mind. For an AI to actually reach this level, it would have to understand human emotions, understand beliefs, and be able to interact socially just like a human does. This type of AI is completely underdeveloped, though researchers are putting massive effort into it as we speak. Beyond that, the final frontier is self-awareness. This is a totally hypothetical future concept where machines become super intelligent and actually possess their own consciousness, their own sentiments, and true self-awareness. At that point, they would literally be smarter than the human mind.
All right, bringing things back down to earth, let's jump into Section 4, Real-World AI in Action. Let's apply this dense taxonomy to some everyday items.
And this brilliantly illustrates how we interact with these different AI types every single day. Take your smart washing machine, for example. That is a pure reactive machine. It just adjusts its cycle based on the current load without any past memory. But your Netflix recommendation system, that relies heavily on limited memory, constantly analyzing your watch history to recommend what you should binge next. Your phone's Face ID unlock, it also uses limited memory to learn and adapt to your changing face patterns over time. Even Alexa and Google Assistant fall right into this category, using your previous conversations to improve how they interact with you going forward.
But what about those crazy futuristic concepts we talked about? Well, if a robotics team built a debating robot that could genuinely understand and reason about social values and abstract ethical thought, that would map perfectly onto the theory of mind category. The exact same goes for a human-like robot that could truly respond to your emotional cues and simulate empathy. And that fully conscious android from your favorite sci-fi movie, that represents the absolute peak of our map, a self-aware AI, a fictional entity with an actual genuine awareness of itself and its surroundings.
To round out this map, let's inject a little burst of energy with some surprising trivia from the history of AI. Did you know the widely recognized father of artificial intelligence is a researcher named John McCarthy? Or how about this one? Back in 1985, a famous human chess player named David Levy beat a world champion chess program called Cray Blitz in 4 straight games. How? Simply by using orthodox moves that totally confused the program's rigid reactive logic. Also, graphic interfaces were first used in a Xerox product called Smalltalk. And when we talk about natural language generation today, just remember that the program must always compute 2 massive things simultaneously: exactly what to say and exactly when to say it.
As we bring this explainer to its climax, I want to leave you with the ultimate definition of where this entire map is leading us: self-awareness AI. It's the hypothetical future where machines completely surpass human intelligence, possessing their own consciousness, their own sentiments, and true self-awareness. Now, it doesn't exist in reality right now, but it represents the absolute peak of the mountain that researchers are trying to climb.
We started our journey today by looking at the "We Are Here" pin, firmly stuck at narrow AI and limited memory. But seeing the whole map leaves us with a lingering, profound question. As researchers push furiously toward general AI and theory of mind, if a machine eventually leaps from limited memory to true self-awareness, how long until that "We Are Here" pin moves forever? Thanks so much for joining me on this explainer, and keep questioning the map as the territory continues to evolve.